Yesterday, we left off with altitude. What's an altitude? What is an altitude? Andy. Very good. It's a perpendicular segment from a vertex to the opposite side, or the side that contains the opposite, or the line that contains the opposite side. How is an altitude similar to a median? How is an altitude similar to a median? Nicole. Very good. They both go from the vertex to the opposite side. They both start at a vertex. Now, how many altitudes does a triangle have? How many altitudes does a triangle have? Amber. 3, and those 3 altitudes are what, Amber? So that means they have a what? Pierce, what's the point of concurrency? Orthocenter. Very good. So that's what we looked at yesterday. We looked at definition of altitude, and then we looked at orthocenter. And today what I want to start with is looking at the location of the orthocenter, and I want to talk about what it means by this part right here, the line that contains the opposite side. That second part of that definition, where it says the perpendicular segment from a vertex to the opposite side, or the line that contains the opposite side, that portion of it deals with the obtuse triangle. And I'll show you why here in 1 second, how and why it deals with the obtuse triangle. So the 3 diagrams I want to draw for you, they are in your notes there in the middle of the page. But I want to draw them for you so that way you can see how we get the line that contains the opposite side. But first, I'm going to start with the acute triangle. Okay, now an altitude. Where does an altitude start from, Daniela? The vertex. Very good. So we go from the vertex to the opposite side, and it's perpendicular. There's 1, 2, 3. And right there, P, that's your orthocenter. Call this triangle A, B, C. So, with an acute triangle, the orthocenter is located inside the triangle. The orthocenter is inside the triangle there. Where the 3 altitudes intersect will be inside an acute triangle. For the right triangle, I'll start my altitude up here in vertex A. It has to go to BC and be perpendicular with BC. Where will my altitude be on a right triangle? Where will one of the altitudes be on a right triangle? Alexis. What? All right, so tell me where it's going to be. It'll be on AB. Very good. If I look, the segment that goes from the vertex A to BC and is perpendicular with BC is segment AB. So right here is 1 altitude. It goes from the vertex and it's perpendicular to the opposite side. Going from C, here's another altitude right there. And then going from B, there's the 3rd altitude. So your orthocenter on a right triangle sits on the right angle. The orthocenter sits right on the right angle. Now the obtuse triangle. Okay. There's the obtuse triangle. Drawing the altitudes on an obtuse triangle. The first altitude I'm going to draw is going from B to AC. From B to AC, there's one of the altitudes. Now, whenever I draw my altitude from vertex A to BC, it is impossible for me to draw a line perpendicular, starting from that vertex, going to the opposite side. That's when this part of the definition kicks in, the line that contains the opposite side. Remember, a line segment is just part of a longer line, hence why we call it a segment. Okay, it's just part of a longer line. So, line segment BC, we're going to take that line segment and extend it out. When we extend it out, we can now draw the altitude from vertex A. There it is. And they'll intersect down there. Okay? Same thing applies whenever I go from vertex C. It is impossible for me to draw that line to AB and make it be perpendicular to AB. So, once again, I take AB and I extend it out. And now I can draw my line perpendicular right there. And there's my orthocenter P, and it sits outside of an obtuse triangle. Questions on that, Lauren? Yeah, the notes doesn't do a good job of showing you the obtuse because it looks like a whole bunch of triangles there, right? The obtuse triangle is on the far right, and you see that P sits on the outside there, on the top. That's a very poor picture, but the picture there where it's like dashed lines sort of on the far right, that's one of the extensions coming out. The obtuse triangle is the bolded one right here. It's the small triangle right there. That's the bolded one. It's just very poor picture. That's why I went and drew these up here, because I don't think the pictures necessarily show it very well. The obtuse, like how you have to extend these lines to get the altitudes on there. The acute and right triangle, I think, is pretty easy to see on the picture, but the obtuse doesn't really do a great job of that. So, when we talk about extending the line, that's dealing with the obtuse triangle. You have to with the obtuse. So, the acute triangle is inside, the right triangle sits on the right angle, and the obtuse sits outside. The orthocenter is outside the triangle. When you look at it in terms of its location, the orthocenter is very similar to what other point? Or it's just like what other point, really? What point is the orthocenter just like? Edmund. The circumcenter, because the circumcenter sits inside the acute, on the hypotenuse of the right triangle, and then it sits outside the obtuse triangle. Okay, the next proof in your packet. There isn't a lot of room in there to write this. We're going to do this as a 2-column. If you have any proof paper, you can get that out. If you have another sheet of paper, you can use that as well. If you need proof paper, I have some. Okay. Okay. In this proof, We have triangle ABC as isosceles. Now, these tick marks shouldn't be there yet. We know that it's isosceles, and we know that BD is the altitude to base AC. Okay. And we want to prove that BD is a perpendicular bisector, a median, and an angle bisector. So, if we look here at this proof, what is it that we're proving? What type of triangle are we given? What are we given here? Yeah, Tyler. An isosceles triangle. What type of angle is B? What type of angle is B? Yeah. No? What type of angle is B? It could be obtuse, we just don't know. But what type of angle is B? In terms of an isosceles triangle, B is what angle? It's the blank angle. It's in section 4.7 in your notes. Angle B is what angle? Alexis. No, not a right angle. It could be. We don't know that. Tyler. No, the angle. I want to know what the angle is. What type of angle is it? 4.7 in your notes. Look it up. It's in the big, thick red packet. In an isosceles triangle, what angle is between the two congruent sides? Pierce. Yes, it's the vertex angle. The vertex angle is between the two congruent sides in an isosceles triangle. So, we have an isosceles triangle, and we have an altitude coming from which angle, Molly? The vertex angle. So, isosceles triangle, altitude coming from the vertex angle. Now, what do we want to prove about that altitude? What is it we're proving about that altitude, Kara? Very good. So, putting this in an if-then statement. If we have an altitude coming from the vertex angle of an isosceles triangle, then that altitude is also a perpendicular bisector, a median, and an angle bisector. That's what we're proving here. Is everyone with me? That's what we're proving. That'll be a theorem here. Okay? So, once we prove it, we'll have the theorem. So, since ABC is isosceles, what else do we know? Keegan. What else do we know? Lauren. Very good. AB is congruent to BC. Justification, Lauren. Definition of isosceles triangle. Good. Keep in mind, we need to prove BD to be a perpendicular bisector, a median, and an angle bisector. We know that AB is congruent to BC. What else do we know now? Nicole? No, we don't know B is a midpoint because this isn't a straight line. Kellen? BD is congruent to BD. Why? Okay? Edmund. Why? We don't have the right angles yet. Why? Killian. I know definition of altitude doesn't talk about right angles. Alexis. I'm sorry, what? Why is BD a perpendicular bisector? It's not the perpendicular bisector theorem, it's actually the what? It's the converse, but you're missing one thing. Nope. What is she missing? Andy. No. Kellen. No. What's the converse? Say everyone go to the converse of the perpendicular bisector theorem right now. Don't quit guessing. Amber, what's that theorem say? If what? If what? Say it again. If what? If what? If what? If in a plane, if a point is equidistant, what are we missing? Nicole. We need to make AB equal to BC. We know they're congruent. We need to make them equal. Nicole, justification. Definition of congruent segments. Okay, Amber, we now have that if part in there. Read on, please. So if a point is equidistant, then what? Then what? So what can we say about B? Kara. So what's BD going to be then? Yep, BD is a perpendicular bisector to AC. Justification for that. Amber. Very good. Okay, that's one of the proofs. Since BD is a perpendicular bisector, what does that mean? What does that mean if BD is a perpendicular bisector? Sarah. Good, D is a midpoint of AC. Justification, Sarah. Good, definition, perpendicular bisector. Now, if D is a midpoint of AC, what does that mean? And choose carefully. Daniela. Yes, you can say that. All right, yeah, I'll say that, sure. AD is congruent to DC. Justification. Definition of what, I'm sorry? Good, definition midpoint. I want to go back to D being a midpoint. What does that mean if D is a midpoint? Nathan? Yes, BD is a median. Because a median goes from the vertex to the midpoint of the opposite side. BD is a median of triangle ABC. Justification, Nathan. Definition, median, very good. Okay, so we have AD congruent to DC. Tell me, what do we have up here? Because the last one we need is this angle bisector. Get this angle bisector. Edmund. Yep, next step, please. Good. Triangle ABD is congruent to triangle CBD. Justification, Edmund. Side, side, side. Very good, Edmund.
Thank you.
Okay, those two triangles are congruent by side, side, side. Now what? Pierce. Angle ABD is congruent to angle CBD. Justification, Pierce. CPCTC, very good. And Sarah, next step. BD bisects angle ABC. Justification, Sarah. Good. Definition, angle bisector. And we've hit it all. So this proof is for theorem 5.9. Parts of an isosceles triangle. And this theorem says, in an isosceles triangle, if an altitude, median, perpendicular bisector, or angle bisector comes from the vertex angle, then that segment is also an altitude, median, perpendicular bisector, and angle bisector. You have them all. Key part of this theorem. What's the key word or phrase? Andy? No. Alexis? From the vertex angle, yes. That line must come from the vertex angle. If it doesn't come from the vertex angle, then this theorem doesn't apply. You can have an isosceles triangle and the altitude comes from one of the other angles. This theorem doesn't work anymore. From the vertex angle, though, it does. Okay? Your assignment for tonight, 5.4, practice C. Numbers 1 through 7 and numbers 9 through 15.